All right, so going over the review where I left off yesterday, starting with number 14. We had talked about 13 yesterday. Like I said, that proof, I just put the answers on the board because that's not how they're going to ask you a proof on the test. And I don't even like the responses they gave because some of those, like I said yesterday, some of them are written as definitions, some are written as postulates, but they don't actually say what they are. Again, normally you'd write it out as the name of the postulate or the definition. So I don't really like the way they did that one. Now, for the other one there, number 14, that one's based on, we have two parallel lines and we have to know our different parts of parallel lines. Again, there's some things I disagree with some of the answers. I did not make this review. This is a county review. The first three I'm fine with. We have angle 1 up here, this one. It's going to be congruent to the 127. We have parallel lines. This line is a transversal that's cutting them. So angle 1 and the 127 that's down here, those two are alternate interior angles. So they are going to be congruent. So it's also going to be 127. Angle 2, which is right next to the 127, those make a linear pair. A linear pair is two angles that form a straight line. So they have to be supplementary. They have to add up to 180. So subtract it from 180 and you're left with 53. Then we go over to the other line. So on this line, there's a new transversal. All right. And we have angles 3 and 4. Angle 3 compared to the 120, they're vertical angles. So they're going to be congruent, and that's why it's 120. Now, angle 4, this is where you could have a couple different answers. It's still going to be 120 no matter what. Now, you could either compare it to angle 3, which is what they did in their answer by calling it an alternate interior angle. So with angle 3, it's alternate interior. But if you compared it with the 120, the original 120, which is what I would have done, they would be corresponding angles because they're in the same position. So whether you put alternate interior angles with comparing it to angle 3, or you use the original 120-degree angle and said corresponding angles, both answers would be correct there. All right. All right, let's go on to the next one. We got number 15. Now, they give you a lot of extra information here. All they really had to give you was that first piece of information about these two lines being parallel. You don't need any of this information that they gave you here in this step. Not for this proof, at least. You could do several proofs using that same diagram, but for the one that they have listed, angle 2 and angle 4 are congruent, angle 3 and angle 5 are congruent. Again, this goes back to the idea of alternate interior angles. We have angle 2 is congruent with angle 4, angle 3 is congruent with angle 5. There are two separate transversals. 4 and 2 are inside the parallel lines, making them interior. They're at opposite sides of the transversal, making them alternate. So those are alternate interior angles. Same thing with 5 and 3. They too are alternate interior angles. So the justification to say that these are congruent is alternate interior angles are congruent, which is A. Now, one thing that you have to be careful of on a problem like 15, if you look at all the answer choices, every single statement there is a correct statement, right? Alternate interior angles are congruent, corresponding angles are congruent, vertical angles are congruent, alternate exterior angles are congruent. Again, you just have to make sure that on this one, they matched what was given to you in the diagram as well. So be careful. On 16, all right, we have a swing set. On this swing set, they told us that these two legs were both 12. That's actually useless information on this one. We don't actually have to know anything about the length of those two. The next piece is what's important. We have this segment here is connecting the two midpoints of these two sides of the triangle. What do we call the segment that connects two midpoints? Now we got these hard terms in geometry, but usually they're quite simple when it comes to actually what they mean. So a segment that connects two midpoints. What do you think? A segment that connects midpoints is called a It's a segment. What type of segment? It's connecting midpoints, so it's a mid segment. So on this one, this segment here that's labeled with the question mark is a mid segment. A mid segment connects to midpoints. And what we're using on this one is the mid segment theorem. The mid segment of a triangle theorem says that the mid segment is going to be parallel to the opposite side. And it's also going to be half the length of that opposite side. Or sometimes they use the word base instead. So on here, 5 feet is what's important. If we know that piece is 5 feet and we know this piece is half of that, how long is it? 2.5. So 2.5 feet. And that's going to be found by, again, our mid-segment theorem. All right, next. 17, still using the idea of mid-segments. 17, I thought was a little bit confusing. All right. First, on that diagram, they tell us that all those segments in the middle are mid-segments. So what does that mean? Well, that means that DE is half of AC. Again, F is our midpoint on this line. So that means that DE, AF, and FC are all the same length. FE, this segment here, is half of AB. Again, D is our midpoint, so EF is the same length as AD and DB. And then the same thing goes for our other one. So DF and those two are also going to be congruent. Now, how does this apply to this question? So they have, or they're talking about quadrilateral A, I'm going to highlight this, D, E, F. This is the quadrilateral that we're looking at. So they want to know which one of these equations is equivalent to the length of the perimeter of that quadrilateral. Well, the length of AF is already highlighted there. The length of DE, same length, could also be represented with FC. So the length of that bottom piece could represent the top and bottom together. All right, then you have, for the other side, AD and EF. Well, EF is also the same length as DB. So the side to the left could be the overall length of both the left and right side of that figure. So which one's equivalent? It is D. Like I said, that one's kind of confusing, kind of challenging. On 18, all right, again, we're getting into some of the ideas of proofs on some of these. So here, they tell us which triangle they want us to use to prove these statements. So highlighting the triangles that they said that we're going to be using, that's important. It's this triangle. And I'll use another color. This triangle. And what do we know about them? Well, right off the bat, we know that we have right angles because they told us that these pieces were altitudes. So we have a right angle in each of those triangles. What else do we have? We have a side that they share in common. The last thing that we know is we're dealing with isosceles triangles. So since we have isosceles triangles, we have a theorem for isosceles triangles that says the base angles are congruent. So this angle and this angle would have to be congruent. So we have two angles and a side, and it's a non-included side. So we can write that as either AAS or SAA. If we look down the list here, we had options of ASA for D, that doesn't work. SSA, that never works. SSS, that doesn't work. And then A is the only option that correctly uses AAS. And it gives an explanation similar to how I just labeled all of those figures. So A is our correct answer. All right. 19. This is more like a question that I would expect to see on the FSA. There's only 2 blanks. All right. And we have a reason and a statement that's missing. We have to figure out which one of these statements should go in that blank. So first, what are we doing? It's proving that the quadrilateral, sorry, giving quadrilateral a BCD is a parallelogram, prove that those two pieces are congruent. So looking at our statements, so far they said, all right, we have a parallelogram that was given. Then they said we have two sets of parallel lines. That's our definition of parallelogram. Then we had a blank. So far, we haven't said anything about congruent pieces. All right. Usually on a problem like this, we'd have to say that we have two triangles congruent. Well, if we skip ahead, step 4 labels AC as congruent to itself. That's this line here going through the middle. It's congruent to itself. Right. So that was reflexive property. We have one piece. But then they go straight to ASA and saying the triangles are congruent. Well, this is just one side, right? This side here is in the middle. So what pieces do we actually need? We need to know that we have two angles and both the triangles are congruent. Well, in this figure, what pieces are actually going to be congruent? Let me get rid of this for a second. Well, we have, again, this line that's congruent to itself. The angles that are next to that, because again, we want angle side angle, would be this angle. Now, is that angle and the angle that's right here congruent? No, it'd be the one over here. How do we know that? Those are alternate interior angles. Same thing over here. This angle and this angle are congruent because of alternate interior angles. Those would have to be the pieces that we have in order to do this, since they're using ASA. So go through the list, see which ones we have. Well, A and B give us more about lines. We don't need more lines. We need something about angles. So then you're left with C and D. We just have to make sure that we're matching up the correct set of angles that are congruent to one another. C mentions ABD. ABD isn't even one of the angles that I've currently labeled. So C is definitely out. And the only option left is D. And D has the correct angles that I just labeled as being congruent. So that would be our missing part of that proof. And so sometimes you have to use the future steps to help find what was missing. All right, on number 20. This one, again, it's kind of about the proof process here. They are saying that we are proving that angle 2 was congruent to angle, what was it, 5, I think? No, 6. Angle 2 and angle 6 were congruent. Well, in order to prove that, so they first use corresponding angles created by a transversal and then alternate interior angles. Well, first, corresponding angles. If we're looking at 2 and 6, 6 doesn't have any other angle labeled that is corresponding to it in the entire figure. So we must have used 2 as the corresponding angle. But what angle is 2 corresponding to? 2 is corresponding with angle 8. So the only thing that correctly does that in the first step is option D. 2 and 8 are congruent because they're corresponding. Then 8 and 6 are congruent because they are alternate interior. And D correctly does that as well. So D is our answer. Number 20, prove the diagonals of a parallelogram bisect each other. All right, on this one, there's a lot of information, but they are telling us what they want us to use. They want us to use these two triangles. So highlight those two triangles. So it's these two. Well, what do we know? We know that this side is congruent to this side. So we at least have one side. Do we have any other sides in these triangles labeled? Not in those two triangles. The only other thing we can figure out is the angles. Well, I can say any one of those angles is congruent. A is congruent to C in the two triangles there because they are alternate interior angles. D is congruent to B, again, alternate interior angles. I could have also used vertical angles here. Say that those two in the middle were congruent to each other. Now, out of these, we had out of those angles, or out of those pieces, we only had one side So can we have A or B as the correct answer? If we only have one side of each triangle? No, because those are both requiring two sides. So can't be A or B. That leaves us with C or D. Now, notice the sides that they're using. The first one uses DP and PB. Are those sides labeled? No, can't be that one. AD and BEC, those are the two that were labeled as being congruent at the beginning. So D is our only one that could be our correct answer. On 22, the figure shows parallelogram ABCD with AE is 18. Now they give us that AE is 18, but that's actually not information that we need to know on this one. We do need to know it's a parallelogram. They also tell us that BE is x squared minus 48, and that DE is 2x. Now, in a parallelogram, the diagonals bisect each other. So these two should be congruent. All right. So we can set them equal. Now, there are things about this question that I don't like. Again, is this a property you need to know? Yes. Are you most likely going to be given a quadratic on this problem to solve on the FSA? No. Again, you'll mostly see quadratics when it comes to the circle section, but we've done a few this year, so I'm going to do this one, and I'm going to use completing the square again. So first, get this set equal to 0 so that we have all these values on one side. X minus 48 equals 0. Now, to solve this by completing the square, again, you could do other methods. You could do factoring. You could do some other things. But I'm going to do solving by completing the square. So I'm going to move 48 over to the other side. So I'm going to leave a blank here. Whatever number is going to give us a perfect square. 48, now that's on the other side, is a positive. And we have to add a blank over there as well, because we're going to have to add the same value to both sides. What number completes our square? We take the middle term, divide by 2, and you square it. Half of 2 is 1. 1 squared is 1. So now that we have a perfect square, this side is 49. This side, we can change into a binomial that's squared. So you take the first term, you square root it. Take the last term, you square root it. You take the sign from the middle. We end up with x minus 1 squared equals 49. Then we're going to take the square root of both sides. So we're going to get rid of that square root by, the square by square rooting. So the square root of 49 is 7. So x must be 8. Now, is that what they want us to find, x? They want us to find the length of BE and DE. Well, BE and DE, they're both congruent, but it's not just x. We'd have to plug it back into one of these two equations. Doesn't matter which one, they should end up being the same. So I'm going to use the easy one, 2 times x. So 2 times 8 is 16. So BE and DE are both equal to 16. All right. The next few deal with constructions. So we did constructions a while ago. This was back in first semester. We haven't seen a lot of construction since. On 23, it wants to know which triangle is constructed congruent to the given triangle. Well, for our construction on this one, this is the original, and all of these are going to start off with copying a segment. So what I just highlighted over, that's the first step. We had to copy one of the segments. Look at 3, look at 4. Neither one of those copied the segment correctly. So those two are out right away. 1 and 2 have that same line that I highlighted going along the bottom with that mark to show that they copied that bottom piece. Once they knew the length of that one piece, looks like the next thing they did was copy the angles that we had on the bottom. So we have these two arcs, and then we have this other arc intersecting it. Number 1 has only one set of the arcs. It doesn't have the other arc intersecting it to know where the other line goes. Number 2 does. So since it has this extra little arc here, this is the one that's correct. So it's B for that answer. On 24, they're making a angle bisector. So they're constructing an angle bisector. Which statement describes point S? So when we do this problem with a compass, we have that point, that vertex of the angle. We swung this arc, right? That's the first thing we did. So now we have these 2 points. Point S is out here. How do we get that point? We took our compass the same length from P and Q and swung an arc so that point S was equidistant from P as it is from Q. So PS and QS had to be the same length, and that is option D. On 25, again, more constructions. This again is talking about an angle bisector, which the following statements must always be true. So going through those same steps again. The first thing that we do is we draw an arc from point O through A and B here, so that both A and B are equal distance from O. So those 2 lengths, OA and BO, have to be the same length. So that first one is a yes, that'll always be true. Then we swing an arc from both A and B out in front so that we have the same length going from A as we do from B to meet at point P. So AP and BP have to be the same length. These other 2, not only do they not make any sense, but if you look at them on the diagram, they don't even look like they could possibly be equal. Again, sometimes you can look at the figure and tell that it doesn't make sense. So both of those last 2 are no's. All right, 26. So it says that she's drawing a circle a square inscribed into a circle using a compass and a straight edge. So what does that mean? We should have something in the end that looks like this. Now, does it have to face that direction? No. So which one of these could give us something that looks like that? Well, they showed us step 1 and they showed us step 2. Right now we have points of intersection here and here on our circle. Well, all we need is 2 more points to make a square, which would have to be up top and down at the bottom. Well, in order to do that, we could do this a couple different ways, but an easy way would be to create a perpendicular line here because the diagonals of a square are going to be perpendicular to one another. So look at our options. The only one that is doing the correct thing is going to be D. Again, we have these 2 points. These 2 arcs that are intersecting are creating a perpendicular bisector, which are giving us 2 more points, which then will give us a square inside that figure. So D is our correct answer. All right. The next few are talking about similar figures and dilations and scale factors. So in 27, we have GH is 1, a dilation with a center H and a scale factor of 0.5 is applied. What is the length of the image of segment GH? So what is the image going to look like? Well, if we know that this original image is 1, all we're doing with our scale factor is multiplying. So times 0.5 gives us 0.5. Our answer is B. On 28. So they gave us this whole image. It says that they are going to be dilated by a scale factor of 2 with a center at P. So P is our center. So P doesn't move. When we did our dilations before, the distance from the center of dilation is going to get multiplied for each and every one of these values. So on here, whatever the distance is, so we have from P to B, that distance is essentially going to get doubled. So now it's going to be roughly down here, UB prime. The distance from P to Q is going to get doubled. So now it's essentially going to be somewhere down here, roughly. P prime. The distance from P to C, again, essentially gets doubled. So somewhere around here, that'll be C prime. And distance from P to A, essentially gets doubled. So it's going to be somewhere roughly around here, be A prime. So our image is going to look something like this. Now, what's true about this? Well, AC and the new line A prime, C prime, they're going to be parallel. And then PQ and P prime, Q prime are going to still be the same line because they were in line with each other. So on here, what's happening? Well, we had AC is perpendicular to, sorry, is parallel to A prime, C prime. Let's see, where is it? That's going to be option B. And then PQ will be the same line as PQ. So B is the only one that fits. Yeah, it helps to draw it out. And the rough sketch is okay. All right, on 29, a line that passes through points 1, 1 and 5, 7 is dilated by a scale factor of 3. And the center at the origin. The image of the line. So on here, most of the time, any line that you have on the original figure is going to be parallel to the other. The only time there's an exception is what we had on the last one. The line passed through the center of dilation. If it passes through the center of dilation, it'll be the same line. Other than that, they'll always be parallel. So if you look at the options here, we have perpendicular to original. That can't happen. We have parallel, which is most likely the answer. We have passes through the origin. Don't know that unless we graph it. And it's the original line. Again, don't know unless we graph it, because if it passes through the center of dilation, then that could be the answer. So let's see. But truthfully, if it passes through the origin, then it also has to be the original line. So C and D, in order for those to be correct, both of those would have to happen. And this isn't a select all. So the only one that could possibly be is B. But again, draw it if you need to. We have a line that passes through point 1, 1. So here's 1, 1. And then 5, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now, it looks like it'll be close to going through the origin, but will it actually go through the origin? No, because it wasn't. The slope's going to take it, so it's not quite through the origin. So B is our correct answer. And let's go over to 30. Same idea. We have our image. Wait, which one is the image? CD is the image. AB is the pre-image. They want to know how we could figure out our scale factor. Remember, we always do new over old. So new goes on top, old goes on bottom. So if an easy thing would have been DC over AB. That was an option. So they're using the original point. So this distance from E to C could be the new, and then from E to A could be the old. Or if I did the other side, it could be ED over EB. Are either of those on there as options? And yep, the first one is. Again, if we look at all the other options, the first one is the only one that makes sense because C is in the new image, A is in the old image. On all the other ones, you had A on top, which is part of the old. So you couldn't ever use that on top. Again, it's always new over old when it comes to your scale factor. Image over pre-image. So the other ones could have been crossed off just because A was on top. on all of the other three. So again, use ideas like that to help eliminate answer choices. On 31, the two triangles are considered similar but not congruent. All right, so what would have to be true? The distance between corresponding vertices are equal? No, that'd be if they were congruent. The distance between corresponding vertices are proportional. So that's saying that the lengths of the sides are proportional. That would be a correct statement for similarity. So B is probably your answer. Check the other ones though. The vertices are reflected. It doesn't have anything to do with similarity. And then the other one talks about shifting. Again, nothing to do with similarity. Those are reflections and translations. Those are congruency transformations. So those don't make sense. B is the only one that has a correct answer. 32. On this one, they give you the lengths of two sides of the one triangle. They say that the two triangles are similar. How could you justify that they are similar by side, angle, side? Well, first, we have two sides on this triangle. The other angle that we'd have to use then would be the one between them for it to be side, angle, side. So looking at the options, there's only two options that use angle A. These bottom two don't use angle A. So you can throw C and D out right away. So now we know that we're looking at A and D would have to be congruent. As far as the sides go, well, which one of these would give us the same scale factor? So if I had 9 here and 12 here, see 9 over 6, oops, 9 over 6 I said, reduces to 3 over 2. 12 over 8 reduces to 3 over 2. We have the same scale factor on both of those. So A must be our answer. If it didn't work, then I'd try B. On 33, triangle ABC was reflected and dilated so that it coincides with triangle XYZ. How did this transformation affect the sides of the angles of the triangle ABC? So it was reflected and then dilated. Let's see, options. A, the side lengths and angle measures were multiplied. Well, will the side lengths and the angles be multiplied? No, the angles still have to be congruent. So A's out because the angle shouldn't change. Only the side should change. The side lengths were multiplied by this fraction while the angle measures were preserved. That might be the answer. I'll come back to it. The angles are multiplied by, nope, that's going to change our angle measures. That's not going to work. The angle measures and side lengths were preserved. Well, that'd be congruency, not similarity. So that's not D. The only one that works is B. I didn't even have to check the fraction because it's the only one that correctly has the side lengths as being proportional and the angles as being congruent. And that's what happens when you have a dilation. So B must be your answer. On 34, Kelly dilates triangle ABC using point P as the center of dilation and creates triangle A prime, B prime, C prime by comparing the slopes of AC and CB and A prime, B prime, and C prime, B prime. Kind of found that angle ACB and angle, and angle A prime, B prime, C prime are right angles. Which set of calculations could Kelly use to prove ABC is similar to A prime, B prime, C prime? All right. There's a lot going on there. Let's see. So our only options when it deals with similarity are angle, angle, side, 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 angle, side. And I think if there's any more that work. I think it was just those three, right? So they gave us an angle. They're not giving us all three sides. So this one's out. None of these other ones are giving us another set of angles within the triangle that mean anything. So I think AA is out. So it has to be side angle side. So we must be doing something that's giving us the length of our other sides, which, so that's going to narrow it down to either B or C. B isn't actually figuring out that sides are proportional. C is figuring out that sides are proportional. So the only one that is going to work here is C. That's a tricky question. Again, did I actually have to do all the work? No, because you could narrow down your answer based off of some of the other ideas of how would you prove that they're going to be similar. You had to use one of those three ideas, either AA, SSS, or SAS. SAS is the only one that's going to work based on the information they already gave us. So it narrowed it down to B and C. C is the only one that's going to be giving us any type of ratios comparing sides. So it had to be C. All right. On 35, given AD is 6, and they have it labeled. DC is 3, and they have it labeled. BE is 4, and EC is 2, and they have them all labeled. Prove that triangle CDE is similar to triangle CAB. All right. So there's a lot of information that was given. You could write all of that in the first blank, which is kind of excessive. But all of this information, since I don't see it listed anywhere else in the proof, could go in for that given statement. Then we said CA plus, CA is equal to CD plus DA. That would be segment addition postulate. Segment addition postulate. And then we have AC 3 that's not really a all right. So they show that these are the same. The only thing I can think of using there is division, which is an odd thing to do, but property of equality. They both equal 3, so we can set them equal to each other. And we're going to stop here since everybody's packing up and I guess it's time to go. Once we are able to say that those pieces are proportional like that, then we have enough information to say that nope, sorry, top angle is the same. So angle C is congruent to angle C. That'd be reflexive. And finally, that'd be SAS. Similarity theorem. All right. Stopping there. Have a good day.